Okay, so today we're going to do the second half of section 3 from the appendix, and we're going to focus on factoring. So at the top, these are all the different kinds of factoring that you have learned from Algebra 1 and Algebra 2. So the first one is factoring out the GCF. So whenever you're factoring, you always want to look to factor out the GCF first. GCF stands for greatest common factor. So you look at every term and you always want to find if there's something they have in common. You always want to factor out whatever the biggest thing is and factor that out first. The next thing you'll look for is if there's two terms. So after the GCF, if there's two terms, it could be a difference of squares, a sum of cubes, or a difference of cubes. So a difference of squares is if both terms are squared and it's subtracting. That factors into a plus b, a minus b. Okay, there's no such thing as sum of squares. It only works if it's a difference. Then you have your cubes. On cubes, you can have the sum of cubes. You can also have the difference of cubes. So if it's the sum of cubes, it would factor into a plus b times a squared minus ab plus b squared. And if it's a difference of cubes, this factors into a minus b, a squared plus ab plus b squared. Trinomials is when you have three terms. Depending on who you had for Algebra 1, a lot of teachers teach it differently. Some do guess and check. Some do split the middle. I will try to focus on using split the middle. But if you want to guess and check it, that's fine. And you're going to end up with two binomials. So that means what I mean by binomials is two terms. So like x plus 2 times x plus 3, that could be what a trinomial would factor into. And then for grouping, you're going to use this if you have 4 terms or more. Okay. All right, so we're just going to do some examples of factoring. So if we see something like 2x cubed minus 6x, well, the very first thing that we always look to do is we always look to factor out the GCF if there's a GCF. So if I'm looking at number 1, the first thing that they have in common is they both have a 2 and they both have an x. So I can factor out a 2 and an x, and I'm left with x squared minus 3. Okay, then I look what I'm left with, x squared minus 3. Okay, it is a squared and is subtracting, but it's not a difference of squares because 3 is not a perfect square. So we are actually done, and that is our answer. Okay, x squared minus 81. Well, x squared and 81 don't have anything in common. It's two terms, it's squared. Well, 81 is squared, so that's going to be a difference of squares. So the square root of x squared is x, square root of 81 is 9. So this would break into x plus 9, x minus 9. Okay, and I'm going to do this one because this kind of shows the difference between like a pre-cal class and like an Algebra 2 like factoring problem. Okay, this is not, you do not need to FOIL or distribute this out. This is a difference of squares problem because x minus 1, that's squared, and the square root of 2 is 4. So this would factor into, well, I have x minus 1, square root of 4 is 2, so I would have x minus 1 plus 2, and then I would have my x minus 1 minus 2. Well, if I simplify a little bit, x, and if I have a negative 1 plus 2, that's a 1, so this would be x plus 1, and then x minus 3. So just because it doesn't look like number 2 and it looks like number 3, this is still a square and it's still subtracting, so I can use our difference of squares method. Okay. All right, let's do a cube problem. So let's do x cubed minus 8. Okay, well, there's no GCF. It's a cube, perfect cube, and it's a difference of cubes. Cube root of x squared is x, and the cube root of 8 is 2. So this would be like my a, and this is going to be my b in the formula. So this would factor into x minus 2. And then I would have x squared plus x times 2 is 2x plus, and then 2 squared is 4. And the one good thing about cubes is once you factor using the cube formula, it does not factor any further. It's not as fun when you go to solve, though, because you have to do quadratic formula. Okay, do a couple trinomial problems. So I have x squared minus 4x plus 4. X squared minus 4x plus 4, there's nothing in common. So then this is where I would want to split the middle. So I do multiply and add tables. I don't know what your Algebra 1 teacher has taught you. So however you've learned how to factor trinomials is fine with me. Okay? So the way I do it is I multiply the first and the last. So multiply to get 4, add to get negative 4 would be negative 2 and negative 2. Since x squared is by itself, I can just make it x minus 2, x minus 2. If x squared is any other number than positive 1, I would have to do split the middle. So I can leave my answer like this. If they are the exact same binomial, you can write it as a quantity squared. Those are the exact same thing. Okay, and so what I was going to say, like a trinomial where it has a number other than 1 in front. So I'll do an example of that. So this has a 3 in front. I cannot just do like a shortcut. Now I can still do my multiply and add table. And I still do the multiply the first and last. So 3 times 2 is 6. Add to get negative 5. So multiply to get 6, add to get negative 5. Would be negative 2 and negative 3. But I'm going to have to split the middle. So I would have 3x squared. And then instead of negative 5x, we're going to use our two terms right here. And I would have negative 2x minus 3x plus 2. And then I have 4 terms. So when you have 4 terms, that's when you factor by grouping. So then the first one I can factor out an x, and I'm left with 3x minus 2. Second one, the only thing I have common is 1, but I want you to pull out the sign, so I pull out a negative 1. And I'm left with 3x minus 2. Just a reminder, when you're factoring by grouping, what's left in parentheses has to be the same. So that is one answer, one part of your answer. What you factored out is the other part. So I have 3x minus 2, x minus 1. Okay, if you see it starting out as 4 terms, then you know you can just go straight to factor by grouping. Yes, you can change the order, like this is not in standard form, but you don't have to change the order. The biggest thing is when you factor by grouping, what's in parentheses has to be the same. So if I group and group, first one I can factor out is a 2x, and I'm left with 3x squared minus 1. Then I can factor out a 1 out of the second group, and I have 3x squared minus 1. What's in parentheses is the same, so that's one part. And then what I factored out, 2x plus 1 is the other. Okay, so on the 3x squared minus 1, yes, it's a squared, yes, it's subtracting, and 1 is a perfect square. But the number 3 in front of the x squared is not perfect, so I cannot break that down any further. Okay, I'm going to do a couple more examples just of problems that I think you'll see similar ones on your homework and that I'll see in the book, and I want to make sure that you know what you're doing. So, I think this is number 8. Okay, if you see problems with fractions, you are more than welcome to factor them with fractions. Okay, I think that's kind of hard to do. That's, I don't think, the easiest way. Now, if you are solving an equation, I would tell you to multiply by the denominator. But I can't do that unless I'm solving. So what we're going to do is we're going to factor out your smallest fraction. So I'm going to factor out 1 over 81. Well, when you're factoring, that's like dividing. So 1 over 81 divided by 1 over 81, that's just 1. So this would be x squared. Okay, but then I would take 2/9, and I'm going to divide that by 1 over 81. Okay, and that would give me 9 times, so 18. And then I would take 8 divided by 1 over 81. And get minus 648. Okay, now, is this ideal to have a huge number right here? No, but this part right here is a lot easier to factor as a trinomial than your original trinomial. Okay, so if I want to know what does multiplies to give me negative 648 and adds to give me 18. I think it's 36, it's negative 18. Yes. So this would be 1 over 81 times x plus 36, x minus 18. Okay, so you cannot just multiply by the denominator. You can only do that when you're solving. All right, and then I'm going to do one more. Okay, so if you see a big problem like this, this is actually just 2 terms. This is your first term, then it's minus, then this is your second term. Okay? So the first thing we want to do is we want to factor out the GCF. So if I'm looking at these, they both have an x minus 2. This one has 2, this one has 3. So the biggest thing they have in common is they have 2 of them that you can pull out together. Then if I look at the x plus 1s, this one has 4, this one has 3, so I can pull out 3 total. So then what am I left with? Okay, well, if the first one I still have the 3. I took out 2 of these, I took out 3 of these, but I still have 1 of the x plus 1s. Then I'm still going to have my 4. X minus 2 is I took away 2 of those, so I have 1 left. And then I took away all 3 of the x plus 1s. Okay, now these outside parentheses I can't do anything with right now, but I can simplify this by distributing. So that would be 3x plus 3 minus 4x plus 8. So that would be negative x plus 11. So I would have x minus 2 squared times x plus 1 cubed times negative x plus 11. Okay, so you do not need to go foiling or distributing all those terms. If you see a lot like that, you are actually still factoring out the GCF. So this will cover everything from the second half of section 8.3.